Welcome to another video of problem solving using data structures and algorithms. Today we are talking about array-based interview problems. So we've already looked at dynamic arrays, low-level arrays, and introduction to arrays. Now we are talking about real interview problems and some strategies on how to solve those. Okay, so let's begin. First of all, because I'm using Python language as the language that you should use if you want to use for solving interview-based problems. So if you chose Python, let's say, try not to use shortcuts in Python if you are answering a question. For instance, this is a very common question asked on interviews. Example for reversing a string. Now we all know we can use this slicing operator to easily reverse a string. But obviously that's not what the interviewer is looking for, but rather they're looking for something that kind of tells them that you understand the entire process and how you can come up with different strategies of doing that, right? So obviously we know that this is like a one-line strategy. Okay. Most array-based problems or list-based problems can be solved using strings and lists. But if you're looking at an improvisation of complexity, look for dictionaries and sets as data containers rather than lists. So that's another strategy number 2. And dictionaries, which are also known as hash tables in other languages, will be covered under the topic hash tables later on. But we can improvise solutions right now. If you're familiar with Python, you know how to use dictionaries. Okay, so coming to the design template that I talked about in the very first lecture, every time we look at a problem, we will try to fill in these 5 things all the time. So obviously we will write the code, so this is quite obvious. But from where do we begin? So the point where we begin is to ask for constraints, then write down our own ideas, and then finally come down to complexities, and then code, obviously. Let's look at an example. So the first example we are looking at is you're given a list of non-negative integers. So that means all the numbers from 0 onwards, 0, 1, 2, 3, 4, and so on. You can start with the leftmost integer in the list. Right? So let's say you're given a list of numbers 3, 6, 1, 9, and so on. For example, if you are at position 6, position means the index, right, in a sequence, and the number at position 6 has the value 3. So you already know in a list, every element has a value. For example, this is value 3, position 0, and so on, right? You need to jump to position 6 plus 3. So simply add the value and the position and keep going on. So in this problem, what we are asking, so maybe I forgot to write, is that how many numbers or how many jumps, you can say how many jumps or how many numbers did you traverse in this process, right? So that's the question. How many numbers did you traverse in this process? Okay, so we will begin with our design template. The constraints. The first thing is the constraints. So the first thing that I'll ask is how large can the input list be if the list size is n? And maybe let's say the answer to that question that you get from the interviewer is that it cannot get over 1000. So you can have 1000 values in the list and you can begin with 0. Right, so this is my first constraint, which essentially tells me that I can have an empty list. So my next question to the interviewer would be that if it's an empty list, what should be my output? So let's say the output should be -1. Okay, so that having said that, that's like my corner case, right? So I know this, I know that I can have an empty list. Also, the other thing is, okay, so this is all about constraints. Let's say these are the, like, we can come back to constraints once like we start with the ideas. Let us begin with the idea. So what we have to do is, I really like to write things down. So let's say I have a list of this kind, like let's say 3, 1, 2, 4, 6, and so on. So essentially what the problem is asking me to do is begin from the element at position 0 and see what's the value of this. It is 3. So 0 plus 3 is 3. So 0, 1, 2, 3. So my next jump would be this. And here I should have counted 2, right? 1, 2. So essentially there has to be some counter that will be counting all my jumps. And here the value is 4 and like my position, sorry, is 4 and the value is also 4. So eventually the third jump is going to be beyond this list. So what should I do when I go beyond this list if my jump is like greater than the list value? So what should I do then? Okay, so maybe the answer to that is count that jump irrespective of where you land, right? So maybe you can land in this one outside the list, right? And then just exhaust it. Okay, so that's another constraint, right? I have to count that jump. For instance, here what happened is that I'll go outside the list when I'm dealing with this. Okay, so that's good. Now I have to come up with ideas of how to do that. So the first thing is obviously check the length of the list, right? My first idea is go and check the length of the input list. If zero, just get rid of, right? If zero, return -1. I already know that. So else is the part that's important. Obviously, the first thing that comes to my mind is I have to loop over this. I have to loop over my list. So loop over list, start with first element, start with first, right? And maybe like this loop will have an index, right? So update index with the current value, with value. And here maybe I should be initializing a counter. Why? Because if you go back and look at the problem, I have to count how many numbers I jumped over. So that counter is going to get updated here, right? So let's say the name is count, count plus equals 1. And that's it, right? And maybe I can have another if statement here, checking that if I jump over a 0, right? Then return a -1, else not, right? So maybe I can write down take care of 0. I'll remember that, right? So this is more like ideas is more about my pseudocode and what exactly I'm trying to do here. Now, even before I start writing the code, let me look at the complexity, right? The first thing is I'll just check the length of the list, which is fine. That's n, size n. I'm going to loop over once only, which means that my complexity in this case is going to be order n, right? Because there is no nesting here, and all I'm doing is I'm checking every value. Then even when I'm taking care of 0, that's fine. I'm just checking every value, right? The whole overall iteration, the worst case is n. So this is linear. That's good, right? We can check maybe if we can improve. And then once I have this idea in mind, I have the complexity in mind, I can go ahead and start writing the code, right? So then comes the part where I write the code. So obviously maybe I can write a function, let's say some jump index or whatever you want to name, and it takes in a list. I'm assuming that you have to write on a whiteboard. Obviously, if you go and print in Spider or some other IDE, that's even easier. So if this length, and let me name it list1, if the length of list1, so all I have to do is just like convert it back now, is 0, right? Then go ahead and return a -1. Else, now here, initialize my counter. And let me use a while loop. Why? Because the increment and the decrement, because notice here what we have to do, right? I have to update my index. Easier to deal with while loop. So that's the only reason I'm using a while loop. I equals 0. So while I is strictly less than length of the list, 1. Keep going. So what you have to do is get the first element. That's where I'm beginning with. I'm keeping it in a variable called temp. It's up to us, right? Whether we want to have this extra step or not. I like to have this variable step. So I'm using it. If this is not equal to 0, remember, because when you are stuck at 0, what happens? What am I supposed to do? So maybe I should be asking that question to the interviewer. If I have a value 0 somewhere, in the list, obviously I cannot move forward, right? I'm at position 0 and I'm adding 0, so I'll stay there forever. So what should we do when we are stuck at 0, right? What should we do when we are stuck at 0? Ask the interviewer, most likely return something, right? So let's say I'll return a -1. So I'm assuming they'll say return a -1. Okay, so if this is not 0, then we have to do something, which is just update the index, right? And how do I update my current index? With the value of temp, right? Else, and also update count. How can I forget that, right? So count plus equals 1. Otherwise, return a -1. So I'm not even return -1, right? And if all of that goes fine, go out of the while loop. I like to draw a line so that I know that I'm outside the while loop. Return count. Okay, I'm really running out of space. Quickly go and check. Let's keep this. Let's go and check the solution to this problem in Spider. And I'll be posting this actually. So this is how it will look like. So let's test this once. And yeah, so there are 4 jumps. You can go and check that there are 4 jumps for this particular list, and that's how you should approach this problem. Okay, let's look at problem 2 because this is about problem solving, array-based problem solving. So let's look at problem 2. Problem 2 is again a common problem asked on interviews, numeric palindromes. If you are not familiar with palindrome, it's a number that takes back that taken backwards remains the same. So if you just like, for example, this number, all these like number 1 or this, and this, these are all palindromes. If you look at this, whether I read it from forward or backward, it stays the same, right? So the problem is asking us to implement a function which, given an integer, computes if it's a palindrome or not. Okay, so let's begin with our template constraints, right? Input is going to be an integer. Again, here a word of caution: if the interviewer is saying it is going to be an integer, try to work with integer and not convert to strings, because I understand that's the first thing, and that you can even talk about it, right? Let's say I convert it to strings. Is it possible? Let's say the interviewer says no, you have to work with an integer, right? Okay, so how large should be the integer? That would be the second thing that I'll ask. Let's say the interviewer answered 10 to 15 digits. This will help me think about the solution, right? The size of my input helps me, because in certain situations I can take that risk of doing an order n squared because my input wasn't that big, right? So that's why I'm asking these constraints. Okay, so essentially I have to check if a number reads the same forward and backward, correct? The first idea that comes to my mind is, take the number. Let's say the number is 945. Let me take a very simple example, right? Store digits in a list. How about I convert this into something like this, right? And then loop through that list, compare the first and last, second and second last, and so on until you're exhausted. If a mismatch is found, return false, otherwise return true. Now, the only issue here is that I'm creating a new data container, which is a list. In like there will be a number, right? And that number can be huge. So first thing is the number. The second is going to be another data container that can be a list here. So there is an additional memory storage issue. Now, if the interviewer says it's up to, like, let's say 11 digits only, let's say the interviewer said your number cannot exceed 11 digits, then I don't care too much about memory and I can talk through that, right? I don't care too much about memory. Why? Because the number is not that huge. So maybe I can go with this solution. So that's my idea number 1. I can also come up with another idea if memory is an issue. So what I can do is get the number of digits in my number. So here, if it's 945, get the number, which is 3, right? Then you can get the left digit by dividing this number, whatever that number is. For example, 945, integer division 10, exponent 3 minus 1. Why 3 minus 1? Because I know the number of digits. So if I do a 10 to the 2, which is 100, so I can get the leftmost digit by dividing by that number, right? And I can get the rightmost digit. That's easy, right? We know if I do a 945 modulus, and I can just like divide it by 10 rather, right? So I can get like dividing by 10 and getting the remainder. So just divide it by 10, right? And get the remainder. So here I'll get the right digit, and then I can compare the left and the right, right? Go and compare these. If they are equal, right? Go ahead and remove them from the number, and then, okay, so then remove them if they are equal and keep going. The moment you find a mismatch, return a false, otherwise return a true. So in a problem like this, I would recommend ask the interview which implementation they want, because the time complexity is sort of comparable, right? Both are order n, but the space complexity is higher in the first one, as I said here. Why? Because, sorry, in the first one here. Why? Because we are creating another data structure, which is a list. So in terms of complexity, time complexity is order n. Space, you can talk through that, whichever they want, we can implement that, right? Let's say they say that space is not a concern here because I'm just like working with up to 11 digit numbers, then that's fine. Let's implement the first one, right? So a good idea is to write down the actual function here. Let's say the name of the function is palindrome that takes an integer n, right? Create an empty list. As I said, I'm naming it array. You can name it anything. while it's better to maintain the structure even while you're writing on the whiteboard. Why? Because it becomes helpful when you convert that to an IDE. So here, and as we discussed, array dot append. So what am I going to append? The modulus, right? Because I'm separating every digit here. So every digit means keep dividing by 10, get the remainder, and keep updating the number, right? Because I have to get rid of that. So keep updating the number and then go and get the length of this list, because this is going to tell you, if I get the length of this array, this is going to tell me how many digits are there. So this is another way of getting the digits out. And then go and iterate over this entire list, right? If the first element and the last element of the list are not equal, then return a false, otherwise eventually return a true. So there has to be another for loop here, as I said, that is going to go over for I in range length of this length of array, whatever that is, right? So I range, but think about it. Why am I going through that entire range? It just like struck me right now. I have a better way of writing this for loop. Let me write it here because there is enough space, right? Why not I go until half of that length, right? Because I is only the index, right? It just struck me right now. So what I can do is length of this array, this variable, right? Go into an integer division 2. Why? Let me just go until half of that point, because using that I can also access the last element, right? So we know this way of indexing. So array, let's say element at position 0, right? If the element at position 0 is not equal to the element at the last position, which is -1, which can also be written as length array minus I minus 1, right? Keep checking the first and the last and just go up till the half of this. For instance, if this was 0, 1, 2, 3, 4, let's go until 2 only and keep comparing 0 and something in terms of this I and the length of the array minus I and so on, right? So we can do that here and then return false if found. Otherwise, just come out of the loop and return a true. Right, so it's as simple as that. Let's actually go and look at the code. If I remember, I do have it and I will be posting it. So here it is, right? So this is what we did. We created an empty array and kept appending the digits. And then eventually, here is that condition that's important, that we are comparing the first and the last, and so on, right? So let's actually see if this works fine. So this is a palindrome, right? As you can tell, let's actually do something to test the otherwise. So that's not a palindrome, obviously. Okay, so this was problem 2. Let's finally look at this problem, and I would encourage you to do this one yourself. Check anagrams. Again, a very common problem that appears on interviews. Given two strings, check if they are anagrams. An anagram is when two strings can be written using the exact same letters. So it's basically if there is a string 1, let's say string 1 is A, B, C, D, and if string 2 is D, A, B, C, they are palindromes because it's just a rearrangement of each other. It's like S1 is a rearrangement of S2 and vice versa, right? So let's go back to our template always. So I'm going to ask the interviewer, how large can the strings get, right? Let's say the strings can get 100 characters. Will they have spaces? Yes. Do we have to, let's say yes. Do we have to consider them? No. So which kind of tells me that I'll have to get rid of those spaces, right? Okay, so if something else comes to my mind later on while writing the ideas, I'll come back and ask about the constraints, ask the interviewer. So that's what constraints are. Okay, so based on these constraints, let's move on to the idea. Let me do this. Remove all spaces, make them the same case, right? Maybe lowercase, right? And yeah, and then start start doing something. First thing that comes to my mind is, how about if I do an s1 dot sort, and this s1 is like after I have removed all the spaces. I know I can do like dot replace or something like that, and dot lower to do that in Python, so that's clear. If I sort s1 and if I do an s2 dot sort, right, we can sort strings. And if I compare them, so it's simply like one if statement, and if both of them are equal, then I'll return a true, otherwise I'll return a false. Right, so this is one solution, and this would be n log n because that's how dot sort works in Python. Okay, the second idea that's coming to my mind is dictionaries. Why? Because this is a very common problem in dictionaries. Using strings, I can count each. So this is how dictionaries look like. I can count, okay, if my key is A, how many A's appear? Let's say 2. If my key is B, how many B's appear? And that's 3. How many C's appear? Let's say 1, and so on. So I can create a dictionary of all the letters in S1, right? And I can count how many occurrences of each letter are there. And then what I'll do is I'll go and check S2 and also check their occurrence, right? And then maybe start subtracting every count of each letter. For example, when I'll go into S2, I'll say, okay, A exists, right? And every A should be like every occurrence of A should be subtracted from this particular dictionary, which is, let's say, called count. So if the occurrence in S2 of A is also 2, if we subtract them, think about it, the output would be 0. So if the number of occurrence of every element is equal, then their subtraction will lead us to 0, right? So if we can test that, we'll eventually arrive at whether the two strings are palindromes or not. And the complexity in this case is going to be order n. Why? Because I'm going to loop over S1 separately, I'm going to loop over S2 separately, and when I access the dictionary elements, it's an order 1 complexity only, as we'll see in hash tables later on. Right, so this second maybe implementation looks better to me because it's an improvement on n log n. So I'll maybe go with that, right? So again, fill this up. We know the complexity, and the one that we are working with is order n, and then write the code yourself. In this video, I'm going to actually take you to the solution that we will be implementing, and obviously this is shown here. So we already talked through the ideas. Here I just remove the spaces from both the strings S1 and S2. Now, this is a corner case that you should be asking the interviewer, right? If just think about it, if two strings do not have the same number of letters after removing the spaces, then obviously they cannot be anagrams. It's like you have a string ABC and the other one is AB. So obviously one is missing, and so that's directly return a false. Now, once I'm done with that corner case, and maybe we should have written that down here, right? What happens here, right? So we should have written that down, that one corner case is if they're not equal length, then just return a false. So that's what this does here. Okay, so now I've created an empty dictionary and I've filled it up with S1, the first string. So here I'm checking if that key in my dictionary does not exist, right? If it exists, then go and update the count by 1. So for example, if this I was A, so let's say A exists in my dictionary count, then go and update it. If it does not exist, go and create it, right? If you find the very first occurrence of A, go and say A equals 1. Similarly, I go and loop over the second string S2, right? But in this situation, the way we discussed our solution, right? So in this situation, what I'll do is I'll keep removing that element. For example, if I found an A and then in S2, and then obviously it was there in dictionary count, if that's the case, remove it. If it does not exist, then just go and create it. Because what will happen is eventually we'll check whether all the elements are 0 or not. So if they are 0, then we have found a palindrome. If not, then you have to return a false, right? So that's what this is checking. If it's not, if even one single element remains that is not 0, that means they're not palindromes because there is a mismatch. Okay, let's quickly test this before we end this video, and I'm going to share the code in the description below so you can go and check that. So well, yes, this is true. They have the same characters, and as we said in the constraints itself, the spaces do not count. So this is how this works, and we have improved over complexity because with the sorting solution we had n log n, and now we have order n. Okay, so with this I end this video. Thank you.